That's good. That's perfect. Oh, I love it. This is perfect. Well, all
Sets
right,
the
let's get
mood.
started. Well, welcome everyone. We're here for another episode of Coffee Sessions. I am one of the hosts, David Aponte, and we have our other host, Demetrios Brinkmann.
Oh yeah.
And we have a very, very special discussion today. We have some very awesome guests. We have Venkata Pingali, co-founder and CEO from Scribble Data. Awesome guy. Please get in touch with him. He's great to chat with. We also have Jim Dowling, CEO at Logical Clocks, and they have some really great products. I've had the chance to try out the demo, really enjoyed it. And today we're going to have a really awesome conversation, something that the community has been looking forward to. We have voted and people wanted to hear about feature stores. And so here we are.
People have spoken.
Yes. And what we're trying to do today is hopefully open up a series of discussions. Today's going to be a nice general discussion about feature stores in general. And hopefully we'll later on be able to introduce some more things. But I think that's about it. Demetrios, do you have anything you want to say about what we're trying to do?
I'm just gonna mention that this is like our first attempt at a panel discussion. So
bear with us,
bear with us, but also it's a first. It's a big first for us.
Milestones, hitting some milestones for the MLOps community.
Oh yeah. So yeah, maybe we should start with something like just breaking down features. I know we've kind of talked about it already, but it would be good to talk about the whole, like what features are, feature engineering, all of that good stuff. And I guess we'll start. Jim, do you want to give us a quick idea on your take on features?
What are features?
Yeah.
I mean, the quick take is, so features are the data that you use to train the machine learning models. But also when you're operating models, when you have models in production, features are the data that are used to make predictions with those models. So that's kind of at that very high level, that's what features are. It's data, but where does that data come from? And I think that's where the feature store is going to come in. I mean, we can take that later, but really it's numerical data, numerical features, also categorical features. That's kind of at the very high level.
Awesome, that's great. Venkata, how about you? I would love to hear your take as well. How would you describe a feature to someone who doesn't know anything about it?
No, I think broadly it's consistent with what Jim was saying. The only thing I would add there is that there is a sort of a landscape of these features. There are qualitative metrics, there is logic sometimes, there is actually sometimes models masquerading as features.
Oh yeah.
In the production system, we seem to be seeing all sorts of features. Something that looks like a simple macro on some existing columns, all the way to, I'm running a full scoring model, and that will show up as a feature for some downstream thing. I think it is if it was just a matter of these simple derivatives, a lot of SQL systems and ETL systems would have been enough. I think the need for this whole conversation and everything else is coming because the complexity of the features is growing over a period of time, and the kinds of things that you want to do and you want to know about these features also is changing. So we are well beyond ETL, well beyond databases at this point.
That's a great point. And I think both of those definitions are great. I would just break it down as anything that describes or characterizes some instance or some example of data, right? So one classic example, let's say we have like an Uber Eats app. It's like, how busy is this restaurant? How busy is the traffic? How quickly they make it? If you're predicting the probability of the disease, what's the height, weight of the individual, the blood pressure, anything that describes something, some instance. But at a high level, yes, it's whatever goes into the model. And nicely following that is this I think it's a great question, is what exactly is a feature store? Because I've already spoken to my coworkers, friends, and we all kind of think about it a little bit differently, which is interesting to me. I think obviously it's a work in progress. Things are changing. Some companies do it a little bit different, but I think that's a great place to start. What is a feature store? How do you think about it? So I'd love to hear from you guys. What are some of your thoughts on how you think about a feature store? Anyone can go.
Yeah, I can start then. So My take on the feature store, it's a platform. It's a data platform for AI. But what it's really about is the problem that data scientists have at a lot of organizations and shops is that how do they get these features? How do they get the raw data they need to take and transform into features and then use them in their models? And what a lot of organizations and shops do is they get a data scientist and say, hey, go use this big data platform, go use S3, go to Redshift, go to whatever backend database, MongoDB, where your data resides. And they're not data engineers, so they don't know how to get the data out of there. And the analogy I have is that you wouldn't get a business analyst using Tableau and say to them, please go to S3 bucket and get that data and transform it to do your analysis. You just wouldn't. And you wouldn't get a PhD in physics to go write a data pipeline to get data from your backend Hadoop platform. So what the feature store is a platform that provides an API between the data scientists and the data engineers so that we get this nice handover of data from the data platform to the data scientists, so they don't need to do all that back-end engineering. They can just go, grab features, transform existing data in that feature store into derivative features. They're not restricted to what's there. They can also compute new features from what's there. But basically, it gives them a nice language-specific API as well. So we're not going to give them pure SQL. We're going to give them Python. That's what they want. We're going to give them Python-based access to the data so that they don't have to do the hard feature engineering and kind of transformation work that typically will be done by data engineering.
Yeah, I like that. Like it's a layer in between the data scientists' research.
Notice I didn't say database once or data store. I can leave that out because it's a little point of contention whether you have to have a caching layer or not. I think you do, but then others may think not.
That's great segment. So Venkata, I would love to hear from you as well. How do you think?
Let me give you a temporal perspective on this, right? In any domain, when it scales, we see newer problems. For a long time, this feature engineering was done by the data scientists at their end, or was done by the ETL and the data engineers at that end. That worked fine for a very long time when you had a small number of models and small number of users. As the number of models, the complexity of these models, and the number of users of these models kept on growing, the suddenly hidden assumptions about this feature engineering systems were coming forward. One of the simplest things is how related are two models? I mean, how do they are they computing the same bits of information? That started coming to the fore because people started noticing that, oh, I'm making the same features, you're also making the same features. Naturally, it's like you'll refactor it out and put it in a separate system. I think the reason we are talking about it in 2020 and not 2019 or 2018 and so on, and the reason your audience on the MLOps forum voted for this is that models are truly going into production. They are starting to notice that there are certain expectations from these features. There are certain guarantees from these features that you need, certain predictability, certain observability. All of these attributes were not something that was people talked about much in the past. I mean, maybe it was happening in the Ubers of the world. Now it is becoming a much more common occurrence. So at some level, you are looking at the evolution of the domain and the scaling of the domain, and we're looking at yet another pattern to standardize, to concretize, to provide APIs like Jim was talking about, so that we increase the overall efficiency of the system.
I think
so it's a natural evolution.
Sounds like in your mind, there's a big part of that is governance, the ability to have accountability over your features, the ability to observe changes and keep track of that. So it's not just a service, it's not just a database, It's also like this place where people can look at and see what's going on and keep track of that. And I think that's actually, you're right, that's a great point to say that, a lot of companies are kind of getting to that stage now. A lot of companies just threw AI at a problem and, started modeling things. But then when you need to productionize these systems, you're like, oh, crap, I need to keep track of all this stuff. It's so easy to get, lost in the sauce of all that stuff. I think that's great. And in my mind, I've heard people, like you said, Jim, refer to it as just having a database. Some people, obviously it's more than that. It's a service. It's something that you can do things with, trigger feature engineering jobs. It's not just a store of values or features. It's something more than that. And I think that it's becoming its own little thing for a lot of reasons. And maybe we can kind of get into some of those things. And one in particular is feature engineering.
So let me just riff off that particular piece, right? Jim is an academic. I have been an academic myself in distributed systems. We will see many forms and shapes of this particular problem and the solutions to it. I think the more interesting question is why does it exist? How does it relate to the rest of the systems? And what are the expectations from this system? And then now you can talk about how the expectations are met. They can, yesterday or day before yesterday, I was, there is now one more company talking about feature engineering, and it was purely SQL based. And for a certain context, it just makes sense, right? For a class of features and for a class of users and the process or the governance needs and things like that. So I think it is, instead of talking about whether it is this particular technology or that particular technology, it's really about what is the problem that this particular subsystem is trying to solve, and what is the requirements of this subsystem, and that will tell us much better what to expect down the line.
Sorry.
Completely.
Yeah. If I can add one more, I think there is the historical analogy I would use is the data warehouse. You go back to the 90s, and people wanted to do analytics over their organizations. The data spread out, lots of operational databases, and then they say, okay, we'll build a data warehouse. And it took 10 years until really data warehouses became good enough that the BI tools that we see today, Tableau, Power BI, Click, and so on, that they became ubiquitous. And now they're ubiquitous. I think we're going to see similar evolution in machine learning and data science. We want centralization of machine learning assets, not just the features, but also the models, and training data sets. We actually differentiate between models and training data in our particular case. But the assets that are generated, you want to centralize them, govern them, discover them, all that kind of stuff. And then tooling will develop on top of that. And it'll be built up stepwise. But I think a lot of people realize that we need to start at the bottom and move up.
Yeah, I think the data is the foundation, right? The model really isn't that great if the data isn't that great. And I think, this is a nice segue into what are features are usually related to feature engineering, feature generation, feature extraction. There's all sorts of words with feature. But I think the reason why there's so many things going on there is that it's more than just some algorithm. It's usually, it's more or just as important as the algorithm, the model itself. A lot of these algorithms are, out of the box implementations are often very efficient, but really the increases in performance, whatever benchmark you're using, are going to come from being creative with the data and really thinking through your domain and how to model that for the model in some ways. You mentioned, Venkata, that sometimes a feature can be a model. Absolutely. Sometimes you can use a feature on its own as something predictive of something else. And so it's made me learn as an ML engineer, even working as a data scientist, that it's very, very important. And oftentimes huge performance gains can come from investing time into creative feature engineering. Brad, you were going to say something, Demetrios?
Yeah, but it would totally derail that thought.
Oh, good. I was just, and another thing is that when we're talking about features, is that feature engineering can be fairly complex. I've seen it be a very creative endeavor. For me, it's like arts and crafts. I'm trying this and I'm trying that out, and I see what works well. And because of that, it can be very hard to reproduce that. It can be very hard to keep track of that. And so it's like very experimental in my experience. And because of that, it's very difficult to, again, manage that. And that's why I think people are starting to realize that there's a lot of complexity that, is going on there. And if we don't spend some time thoughtfully organizing that, it's going to be very difficult downstream. Would you guys agree or have any thoughts on that?
Maybe, and also we can maybe like look into this creative feature engineering side and how to become more creative with your feature engineering, and if there is like how a feature store can help, because I'm sure that if you have somebody that is on the team that just nails it when they get very creative with their feature engineering, how you can duplicate that across the team and really take advantage of it. So yeah, maybe Venkata, can you talk to the whole idea of this creative feature engineering?
But let me take one step back. The part that David was pointing to. See, when we are thinking about feature store, we are like almost now somewhat solidifying all of these things. They are not experimental anymore, right? So the feature engineering as a step is is turning into a two-phase activity. One phase which has to do with this relatively predictable engineering like implementations. They are computed day after day, reused by many models. And then there is a model specific feature engineering where there is a lot of creativity, deriving more features out of the existing features. Once a particular model finds that there are interesting features, then the way to propagate it and make it available to everybody else is to push it back into the engineering system, which is our feature store. So the best data scientists, in my opinion, are those who are able to combine deep insights into the domain. For example, in fintech, how exactly the decision process, financial decision process happens with the statistical characteristics of the data and a bunch of experience, all the patterns that they have seen in the past. I think I would disagree with you when you said earlier that the models are getting a little more commoditized and baked into the algorithms. I still think that there is no substitute for judgment, right? That is still a long drawn out process. People learn through experience, trial and error in various situations by staring a lot of time at data. No amount of AutoML is going to do it in my opinion. So I have not seen a recipe for good features. I have seen a lot of expression of this judgment and understanding and thinking and debate and so on. I think what the feature store now enables you is that if there is a creative individual in your company who's able to extract great signals from your data, now suddenly it is available to everybody else in the company, right? So that information search becomes so much more faster. Jim, you want to add thoughts?
Yeah, I'd agree with that. I mean, I think Twitter have a metric called the sharing metric, where they really they're trying to evaluate the success of their feature store by the number of the features shared across teams. And I think just getting that insight and seeing the definitions of the features, the jobs that are used to compute them, the notebooks or the Scala code or whatever the logic is, helps you on the way. I mean, I think the question Demetrios had was about creative feature engineering. I taught the first ever deep learning course in Sweden, so I have a particular affinity for deep learning. And we had one interesting problem with a bank, and we trained a deep learning, a GAN, a generative adversarial network, on 40 terabytes of data, okay, to predict anti-money laundering. Okay, so we needed a lot of GPUs, and it took a long time to train it. But the most creative thing in that was the feature engineering, and it was one particular feature actually. And the result was we beat the state of the art in terms of the existing anti-money laundering schemes. They do rule-based matching. They have 1,000 rules, and the transaction arrives. You see if it matches any of these rules. If it doesn't, it's okay. Otherwise, you generate a warning and try and alert and try and figure out whether it is money laundering or not. But in this case, it's really just a binary classifier. It's going to say if this is money laundering or not. Obviously, it's currently an adjunct to the other platform. You can't just trust it again to do that for you. But the challenge in that people who do money laundering, one of the rules they know are very hard to get around is to do small payments to different people who aggregate money and then send them to other people, because they keep under the radar of all the rules. And the insight that we had to discover this was to draw the graph. So if I be a person who's sending money or receiving money, so an edge is a transaction of money. If you can do a search from any individual in this graph, a couple of hops, you're going to get quite far. So the properties of networks. When you have a lot of edges, you'll have potentially tens of thousands of vertices you can reach in just 2 hops. You couldn't just push all this directly into a deep learning network. You couldn't say, I'm going to take all my 3-hop neighbors and just create a vector and push them in. We use something called graph embeddings. So it's a way of taking a snapshot of your graph and converting it into a vector, a small. It's compressing that information about the graph in your neighborhood, in any individual's neighborhood. And you need to do that periodically. You can't just do it once. You do it if you're doing it every day or every week, or you're recomputing it. So this was actually a huge Spark job running for a long time. And it was way more complex than actually computationally complex than training the model itself. And I think that feature alone made such a difference,
Yeah.
So, I think Andrew Ng, just to finish, Andrew Ng, who's quite a famous professor from Stanford, he once said, all applied machine learning is essentially feature engineering. And I think there's some truth in that.
Yeah, 100%. I like both of those points.
Yeah.
And I think, go ahead, you were going to say something, someone?
No. I mean, that is a great reflection of your understanding of real world behavior, right? What are the incentives that people have? What channels do they have? And the interesting thing here is that you're combining the understanding of the behavior with the fact that you can construct these long-term relationships between individuals in data. It is the good combination of data and the intuition that makes for good features, in my opinion. There was a banking customer that we were talking about. And so the bankers wanted to embed things like they were making subjective assessments of this individual, right? When they go meet these individuals, right? With some layers of control and training and things like that. They were talking about how they were able to get fairly good understanding of the customer by capturing all of these things, these behavioral parameters over a period of time. Of course, there are lots of questions about whether it is reliable and this and that. But nothing in my opinion beats the experience, intuition, and understanding. That is still, the judgment is not substitutable.
Yeah, I think that's, for me, feature engineering is about encoding all of those insights and those, maybe even assumptions, priors, maybe you want to phrase it. And
so now in this case, right, the ability to first have a system where you can express this, be able to reuse it over a period of time across models, standardize the definitions so that there is no confusion about all of these things. If there are judgments that are made, then we actually have the ability to audit and trust these. These are all the additional checks and balances that the feature store can provide.
Yeah, it's great. And I guess to Demetrios, it sounds like feature stores help guide that creative endeavor. Feature stores help reproduce that thing, help there be discoverability, traceability, all of these attributes that you need in a production system. And this goes nicely into the next component is, why do you think we need feature stores? I mean, we've kind of been, getting at that little by little. We talked about the complexity of feature engineering. We talked about features. Jamie gave a great example of how complicated some of that can be. So let's start with some of the points of why, a company may need a feature store. What are some of the reasons why?
Yeah, I can try and answer that. We actually work mostly with data teams, so data analytics teams from warehousing, business analytics, and so on. And they're normally the people who approach us because they're the people who have the pain point right now. The company has decided they're going to invest in data science and AI. Their data all resides in data lakes, data warehouses, and they need to get that data somehow into the hands of the data scientists. And they go, I don't know how to do it. And then they Google around and they find out about Michelangelo, and they get a little bit of platform envy and say, well, I want one of those too. And then they go out and figure out, will I build it or will I buy it? And I think, when you see people use it and they'll see the value that's created, I think just working on, if you do many models, more than one, right? Once you start producing, and we've been using banking as a common example here. There's a type of feature called know your customer data. Every bank has it, and it's credit scores and all that kind of things. That's reused in so many different models, and just being able to take those features and combine them with other data and get a training data set that is clean, it's in TF record, ready to go with TensorFlow, it's in NumPy for TensorFlow or for PyTorch, or it's in CSV for scikit-learn, and just removing the pain of getting that data into the clean trained data set you want to do. And if it's big data generated overnight, it's ready in the morning when you get to work. I mean, just those things are going to make such a difference in data scientists' daily lives.
And going back to that whole money laundering thing, how did you stop it? Like, and what can we do if we need to money launder and get past that GAN?
Yeah. Reverse engineer.
Yeah.
No, I'm joking. I thought that was.
I can say basically it's a non-detection problem at some level. So using a binary classifier, training it on what is considered normal data that you have labeled small events of, and then you have this massive class imbalance. There's really, really challenging problems there. But reverse engineer would be one way. Have your own model and see if you pass your own. But then that guarantees nothing.
Yeah. And Venkata, what are your thoughts on why we need feature stores?
So we've been in this business for about 3-4 years, around the time when Hopsworks started out. Our market is a little different, but we've seen the evolution, and it's clear to me that what will drive this is economics. The moment you have 3-4 data scientists who have to coordinate, the moment you have a few models and a few versions of this, the chaos is enough for you to step back and ask, is there a better way to organize this? Now you will start thinking in terms of feature stores. Now it's a question of how complex a feature store, buy versus build versus and so on. Until recently, there were no options. So everything was a build option only. I think that because this is, in my opinion, fundamentally tied to the scaling of data science, and the size of the teams, the number of models, the amount of data, we think it is inevitable that every organization will build a feature store of their own. Once they cross a certain scale, they have to have a person-independent, standardized store where they can go and get your features programmatically or through for analytics teams through other interfaces. And it's now really a question of where does that where is that point where it makes sense for you to now invest in a separate system with all of its additional costs, complexity, and all of those kind of things. The interesting pattern that we have observed is that it is moving earlier and earlier in the journey. When we started out, our customers had, there used to be these billion-dollar companies. Now our customers are from fintech-like domains. They have barely raised their series 1 with 3, 4, 5 people teams, and already they're thinking in terms of feature stores, because at some level they have internalized this idea that we are going to produce more models. Now it's about just removing the friction in the whole process so that we can do more of them more often and do it more aggressively. So it is fitting into the larger productionization story and the larger MLOps story. That's why you see that the MLOps suddenly became very big topic in the last 1 year, right? It's not that it wasn't there before. Now it is scaling up, as in the community. The number of people who are thinking about this is growing.
Yeah,
To me, it's just economics.
Yeah.
yeah.
I have a point on the feature store and MLOps, right? And this is something that we've been around a little bit, and we were a bit involved in TensorFlow Extended. I mean, we had an implementation of Beam for Flink and on our platform, and we really thought TensorFlow Extended was a very interesting way of doing end-to-end machine learning. And pretty quickly we discovered actually you need an intermediate place, right? From where, because features are being engineered, and they're being engineered for operational systems. Maybe they'll be updated every day, or maybe every hour, or every 5 minutes, or 30 seconds. They're all arriving at different rates. And if you have end-to-end pipelines the whole way, it's like there's no intermediate place where your transformed data is cached and reused. There's no way to organize it. And it just didn't. And then for operational systems like the anti-money laundering one, in that case, we just have 6 features arrive when a transaction arrives. We just get the IDs of the customers, the amount of money, the banks involved. Hang on, we trained it with 250 features. So those features don't exist in the online application. They're historical data, contextual data, and then you just do a lookup in real time, low latency, to the feature store, get those values, and then boom, you can do your inference with that feature vector. And so the whole end-to-end kind of that thing just kind of fell apart for us, and we just said, hang on, there's now 2 MLOps pipelines. There's one to the feature store, and there's one leaving the feature store. And actually, we're kind of in a place where we think there's 3, but that's kind of debatable. After you train, you then kick off a Jenkins job to do. You should be doing model validation and deployment canaries in another pipeline. So it's potentially 3 pipelines. Your feature engineering pipeline is one MLOps pipeline, model training another, and then model validation and deployment your third one.
Sure.
Yeah, there's definitely a few things that I'm like trying to parse out here to summarize. One of them is there's a lack of reuse, right? We need this ability to consolidate common methods, facilitate easy sharing and versioning. We need reproducibility. We need quality checking. Serving features is non-trivial, making them available for these different types of applications. Having a single source of truth, right, for visibility, for discoverability, to promote trust, right, because that's a big thing. You mentioned also there can be an inconsistency between the online and the offline setting, so to mitigate some of the issues there, possibly concept drift, things of that nature. And this one thing that I think me and Venkata were talking about this offline a while ago is just the need to support emerging requirements. You know, things change, and the team will evolve, the system may evolve, and you need the ability to modify that, to iterate quickly, to help that thing grow into this new system. Maybe Venkata, you can kind of touch on that as well, because I thought that was a really interesting point. The need to
I want to say real
experiment, and go into production. You have all these changing requirements.
I'm happy that you're able to summarize this quickly, David, because I'm still stuck here thinking about money laundering in Sweden and how I can go about it.
You can take this conversation offline with Jim, and I'm sure you have some insights about what breaks in a system, and exactly those are the things that
exactly.
I don't want the Russians coming after me.
Yeah, they'll hire you.
Go ahead, Venkata. I thought that was an interesting point about the need to support these emerging requirements.
The emerging requirements. So the biggest driver that I'm seeing for all of our conversations is trust. Now there is a lot of sensitivity around use of these models and use of this data. We surveyed the GDPR-like laws, and they're pretty much there in all geographies now. Then now the lawyers are already talking about the algorithmic accountability, and from there the product liability. So the risks associated with use of ML and data is growing across the board. And a lot of our newer requirements, asks are coming from that direction. So one of the things that we are finding is that suddenly they are looking at the feature store as a policy enforcement point. Let's say the company has a privacy law. and now there are like 50 of your data scientists who are using. Where would you put that, enforce the privacy law that the company has, or ethics review, or and things like that? And that will happen at the feature store. And the privacy questions are showing up more and more often in our conversations. And in fact, some of the extensions of our features are all of our feature store are in that direction. For example, being able to continuously assess the risks associated with this feature data, right? Crawl all of the data sets that you have ever generated and wherever they may be, and start associating risk with them, because that has to feed into their larger governance and the risk and the privacy requirements of the organization. So we are trust has always been a big thing. I mean, that is why we the reason Scribble started building this feature store was when a few years back, when we started out and we were doing modeling analysis and things like that, there was a series of embarrassments arising out of the data, the lack of integrity, the lack of discipline, and that is what triggered us to start building a set of checks and balances around it. Today we call it a feature store. The trust has always been there, but the change that we have noticed is that people used to not pay attention to it some years back. Now, this is one of the first questions that is coming to us whenever we talk to any clients.
Yeah. It sounds like it's not just an engineering problem. There's a human problem also that's a part of features.
Correct. In one of our clients' case, these features that are generated are not immediately surfaced to the end users through models or whatever may be the consumer. It actually goes through an ethics review board. The review board says these features are okay or not okay, and then the approval feeds back and the spigot opens, if you will, from the feature store. This is something that I had not seen before, and this was not an ask until about 6 months back. Now we are seeing like customers asking for it.
Okay, you're going to say something, Jim, sorry.
Yeah, no, it's echoing Venkata's point there about risk. I think there's increased understanding now that a lot of risk in productionizing machine learning applications derives from the data rather than the algorithms. I think there was a big debate on Twitter recently where Jan LeCun got involved, and he said, there's no bias in the algorithms, it's just the data. Yeah. And I think Venkata is right that, what we can do in our feature store when you ingest data to the feature store, we group features together in something called feature groups. So it's a data frame API effectively. You want to ingest data from a back-end system, typically from a table, you might transform it or compute aggregations. You ingest that into the feature store, and you typically will update it. It's something we call an upsert. So every time you update it, you have a bunch of new data coming in, and you compute statistics over those features, and then you want to apply data validation rules. You want to compare distributions of features. You want to make sure that, for example, some gender or racial group or something isn't over or underrepresented compared to the current data that's in there. And then you want to get early warnings, before this data is then brought out into live systems as well. Yeah. So I think there's a good understanding that feature stores can contribute to mitigating risk when deploying, operational machine learning applications.
This is one reason why you were asking earlier, why will feature stores exist? This system has to give these guarantees, right? Guarantees of correctness, guarantees of fairness, even going towards explainability, auditability, all of these, something has to provide all of those guarantees on your data.
And from a technical perspective, a traditional data warehouse gives you schemas, okay? And schemas are not enough in this case.
Yeah.
In this case, we need properties of the actual data. So we need to know valid ranges. We need to know data drift, feature drift. We need to know that our data is not going to blow up a model when we train one.
Okay. Because all the questions are all point in time. As of 3 months back, right? 3 months and 2 days, we made a decision about something, right? Can you show us how we have arrived at it? because the person who has been impacted by the machine learning decision is not going to realize immediately, or he or she. They're going to realize sometime down the line that their loan has been denied, and then they'll come back and ask, have you been fair? Show me that you have been fair. So the ask, in fact, I posted yesterday or day before yesterday, even in these early stages, even before in India, before the privacy data protection law went into the effect, the e-commerce law has explicitly asked for explainability in your models. They've given it in writing that you have to do this, right? So I think that there is a broad convergence that you need to build trustworthy systems, right? And all definitions of trust.
I think, yeah, I mentioned this earlier, but it's much more than just a technical problem. There's also like this, I don't know, human cultural component, however we want to phrase it. And trust is huge. I know in my company, that's a big thing. A very much human in the loop sort of process. Companies that have that, that's huge. So now I want to, one of the last things I would like to cover is to scratch the itch of all the engineers, all the people that are super interested in details. Is as I've been doing my survey of all these different feature models out there, I've noticed that there's some common architecture, common patterns that I've seen. And I want to kind of go through some of these points of the things that I've seen in common. In summary, I've noticed that there's some offline component, some online component, there's maybe the ability to do engineering jobs. Some of them provide a domain-specific language, maybe an API, a software development kit, some metadata. So there's all these different things. But let's start with this offline component. I noticed that most feature stores have the ability to store offline features, maybe using a Hive database, maybe using BigQuery or S3. But typically this is happening when you have batch features, things that maybe time isn't really that important, maybe that you can do it in bulk. Let's talk about that a little bit, about the offline component of feature stores.
Go ahead.
Yeah, I can say a couple of words. I mean, I gave the example of 40 terabytes in the anti-money laundering case, and really the way we see it is you should design for distribution. You should build it once, and so that you could do everything in Python. I think we see in machine learning and deep learning that larger data volumes do give you better models ultimately. And there's academic results showing a logarithmic improvement in training performance or generalization error with increasing data sizes. So you should have an offline store that scales. So whether it's S3 or Hive, or BigQuery, that they're scalable platforms, and I think that's where that need comes from. But then the online, you can get the online later, but that's kind of my take on it.
Great, thank you, Jim. How about you, Venkata?
I'll reframe it a little bit. See, there are three big tasks that these feature stores are addressing: the generation of the features, the management of the features, and then the serving of the features. The storage really has to do with the serving of the features. It doesn't tell you what is actually coming in, right? So the design space that you are looking at has to cover all three of them. You may be still, for example, one combination is all the features are being computed in Spark, and then they're going to S3, or they're going to a Hive table. Or you could have pandas to Redis, right? You may be computing in pandas, it may be getting stored there. I think that depending upon the size of your organization, the complexity of the features, where you are in the journey in terms of the number of models, you will see a variety of design points here. And I don't think it is about one or the other. For example, the big thing, my customers, the reason they are talking to us is not because they didn't have the Spark infrastructure or even the Hive infrastructure and so on. The data that was going into the Hive was the problem. That didn't have the kinds of guarantees that they needed, right? So they never talked to us anything about the serving, that they had that nailed down in their overall system, right? A lot of their emphasis was what an extensive validation, how extensive can your validation be of the data? How fast can I do the development of all the different features in my organization, and so on. The questions were a little different. So my suggestion to the audience is that there is plenty of innovation that I think we will see on the part which allows ML engineers, data scientists to express the features. There is part that is about computing these features. There is the part that has to do with discovery, search, documentation, and development of these features. And then there is the last part which has to do with the serving of all of these features. And you'll find, I think, because of the diversity of the companies that are going to adopt feature store, it won't be a small number. It will be a large design space with many feature stores. You'll almost like dinosaurs. You'll find many versions of them, in our opinion. We are mid-market. We make particular assumptions about what the data team's capabilities, size, need are. The Tectons of the world will go a certain way. The Hopsworks will go a certain way. I think there will be many more that will come over the next 2-3 years.
Wow. So this offline component is huge, right? You said it's usually, obviously a lot of companies do that, but then there's this other component where you need online features, you need things in real time, and maybe you need something that has low latency, quickly read from it. So maybe you're using something like Cassandra, or like you mentioned Redis, or maybe even you have your own microservice. But this is also a very important component. And in fact, a lot of the people that I talk to about feature stores usually think about this component of having online features, the ability to have them in obviously in a fast way, in a consistent way. You mentioned earlier, Jim, about they generate all these cool features offline, but then they won't be available in real time, right? Let's say, depending on your application. But I think this is an important thing. This is a challenge that a lot of companies are still trying to deal with, this balance between the offline and the online features. So maybe we can talk a little bit more about that.
Yeah, I'll have a go. So I think one thing that we understood quite early was we wanted to reuse features. We wanted features to be reused in many different models. So whether it's offline or online.
Yep.
And if you don't reuse them, what you end up doing is you end up writing a new pipeline every time you want to deploy a new model, because it's going to be a new training data set for that model. So we want those to scale independently. So we have this concept of data frame API, where you would have a pipeline that takes that data frame, writes it to the feature store, and then you're done. And on the other side, the data scientist will join the features. We'll say, I want these features together, and there will be some way of joining them. And there's going to be a key, and it could be a temporal key, it could be a primary key, or some way we have to join those together. And if we're doing that offline, we do it in Spark, in our case. And Spark is quite popular because it's pretty powerful, and it can handle large volumes of data, and it's easy to transform the output into TF record or CSV or NumPy. In the online case, this is where we have a lot of divergence, I think, in existing feature stores as to how people do this. So what we do is we will do online joins. So the backing database in our case is an in-memory distributed database. I worked on the team 15 years ago. It's called MDB. It's developed here. We work with the people who develop it. MySQL cluster is the more common name for it. It's not normal MySQL. It's not InnoDB. When you turn on your phone, 60% of the time you're using it. So it's well known in the telecom space. It's open source as well. But that particular online database gives us the ability to just write the features to the online feature store once. And then when we need to reuse them, like know your customer data, we can just join them with other ones in real time. Now, and you can say, well, what's the P100 on that, or the P99 on that? Well, it's still very low, right? It's still single-digit, double-digit latency, millisecond latency. And I think that's where many different teams have diverged. When people are using key value stores to do this, well, the joining capabilities disappear, and you're into writing different pipelines for every new model that you productionize for operational. So I think that's a key differentiating factor between many of the systems out there today.
I would concur. One definite thing I think is that because the real time from an operational standpoint and development standpoint, it's more difficult than offline. I'm already sensing that some standard design patterns will emerge there. For example, a standard thing that I'm seeing everywhere is Kafka to Spark Stream to Redis, right? That particular thing. The thing that Jim pointed out, which I think will emerge it's just a matter of time, which is that these two have to be in some sense pulled together, whether it is in time, the quality of the data, or the granularity, and so on. So you will effectively be doing join between the real-time stream and the batch stream, right? You could go down the path of Feast, which is using Beam and a single SQL, which is doing both of them. But these are all fairly complicated systems to build and operate. So I expect that in the shorter term, there will be fewer design approaches in the real time. They will be still decoupled from the batch, but a year or 2 years from now, we will have to start in some sense finding a much we have to have a much greater integration between the two. Otherwise, we won't be able to serve the next generation of the applications. So to me, it's just a matter of routine. Now here, that requires us to gain a little more experience as to what kinds of joins actually make sense. And accordingly, from there, infer the kind of underlying systems that need to be built for this.
And let's do one more thing that's pretty common is the ability to generate new features, right? To run a feature engineering job. So, there's a lot of focus on having, like you said, a training pipeline, but we also need that for generating features, because sometimes it can actually take a long time. Like I know I've worked with large graph databases at my job, and sometimes calculating something simple like 2 hops can take a long time, and it can really, get big really quick. So let's talk a little bit about that. A lot of these systems are using things like Apache Spark, Apache Beam, Apache Flink. Something that's fast is what is like the way I think about it. I need the ability to do this in a fast and consistent way. Maybe the ability to configure those transformations in a creative way, build new operators, do things of that nature. But let's talk about that last component before we get to our questions to close of this feature engineering jobs.
Yeah, I mean, I think Spark is dominating data engineering now, outside of the Google cloud, where Beam and Dataflow are still reign supreme. So I don't see that changing in the near future. It's a pretty powerful tool. Obviously, Pandas is great, and you can do a lot with Pandas. We support pure Python and Pandas now as well, and Kubernetes, but we still see a lot of people working with Spark, and PySpark in particular.
Yeah, I mean, I think that the economics of the overall data platforms will drive this. It is very expensive to set up these Kubernetes and even Spark clusters, run them. The bills, my clients complain about Amazon bills, right? I think what will happen is we will see something that is fit for purpose, right? If a lot of the data, if it is terabytes now, you have tasks and pandas like systems which will come, and very soon probably Ray also will be an option. So I suspect that depending upon the scale of your data, you will have various choices, and it's not a given that you will always use A or B. I have seen, everything from Presto clusters to Hive to Spark to Pandas to everything. I mean, it's a jungle out there. I think because these data systems are turning out to be fairly complex and expensive to build, run, and so on. So some correction is in order.
So I wanted to ask one before we finish. What was that? Sorry?
Do you agree, Jim?
Yeah, I mean, I agree. But the only thing I'll add to that is I think it'll be code and not UI driven platforms. I think these will be written in software. It's just moving too fast, and UI tools will be hard for them to develop.
Great points from the both of you. I have one question I want to ask before we run out of time, and it's to scratch my own itch, because I've asked this before when we were talking to Kevin from Tecton, and I wanted to know if you have ever thought about, or if you have it on, like Jim, you were talking about earlier with Twitter, how they have this like shareability feature, and it just shows, or I can't remember what exactly it was.
Sharing metric.
Sharing metric, that was it. And so I would love to see the like metrics or something like that, where if my feature just ate up, 10 grand in resources to create that kind of feature, like you could see that very clearly. Or if my feature is the one that has been used the most, like I get a special badge, and if my feature is the one that has been used the least, it's like I get another badge. So I'm wondering if either of you have thought about that, or if you haven't, what that looks like.
Just let me create the gyro here while we're talking here. I think it's a great idea. I mean, but again, it depends on the culture of the company, So our head of cloud he's a former head data engineer at Spotify, and they had no insight much really about how much money they spent, except one time he ran a query and someone knocked on his door from the operator. That was a very expensive query. So I think it's if your behavior is reasonable for the cost aspect. I think for usability, absolutely. In machine learning, we've always had competitions. So we've loved leaderboards, and this could be the leaderboard for the data engineers and feature engineers out there.
That's great. I hope that happens, because that drives a lot of change, right? A lot of creativity, a lot of awesome solutions. Go ahead, Venkata. I didn't want to interrupt.
No, just one thought on that front, right? Implicit in what you're saying is that all features are not equal. Some features carry more information, value, and so on. And we know the corresponding cost, which is computing all of these things day after day, maintaining it, updating it, and so on. So in my opinion, so we have one of the things that we have in our feature store is we are explicitly calling it as a marketplace, right? And we have an integration with MLflow to pull information back saying that, is this feature being used at all? Because we, from an operational standpoint, we can see the costs of it. The question is there value to all of these features? So in my opinion, the economics of the features will almost make it inevitable that there will be a marketplace. Some features will be reused more than others. Whether it translates into badges and further incentives for an individual, that depends upon the culture. But to me,
it's non-trivial. At one point there, and then know your customer data at the banks. Everyone's going to try and get that out there because they're going to be super popular. But then the cost of computing it on a Spark job might be very small, but the cost of the data it came from was enormous. And you'll say, oh, the cost was very small. I just took it from there. But there was some cost in that feature from the data warehouse. So there's transitive costs there to take into consideration.
Yeah, I almost imagine next to the feature, there is a price of this feature button or value. And the price can be all of these things. Could be about what data set you have acquired, or could be about how much risk is associated with this particular feature, use of this feature, and how much maintenance costs are going to be associated with it, and so on. So I think that is a slightly advanced state. I think that we are still in the process of just building out a feature store for every company on the planet. As the modeling increases, I think by about 2024, 25, we should expect to see prioritization of the features. It will show up in that fashion. And then review processes where you have to, data scientists or ML engineer have to step forward and justify why this feature is worth putting into your feature store. I think those are all coming.
Those are some really great, interesting points, Demetrios. Thanks for that question. I like that a lot. I would like to close out with this, guys, and I'm sorry if this throws you off guard. But for everyone listening in the MLOps community, one of the things that me and Demetrios want to do through these sessions is promote best practices, things that the experts in the field like Jim and Venkata have learned and want to share. So I would love, before we leave, is there one like little nugget of advice that you guys would give to ML engineers and data scientists? It doesn't have to be something specific about feature stores, but anything related to that space.
I give the point, I'm going to repeat myself slightly, but break up your monolithic end-to-end pipelines. I mean, if you do it with a feature store or not, I just think monolithic end-to-end pipelines is a nice idea in principle, but in practice, it's very hard and can be extremely expensive. You know, recomputing things that don't need to be recomputed.
Great, love that. Separation of concern. Go ahead, Venkata.
Yeah, almost all of my thinking is around trust, right? One is there is real cost associated with it. The problem is that if you don't believe your data, if you cannot answer, is my feature trustworthy enough for me to build a model and 10 other models, it doesn't matter what other efficient systems you have. So my, the one that I would suggest is that it is not about simple or complex features, but it is really about having features that will build trust in your models and among the stakeholders, making it explainable, making it robust, making it readily available. These are the things, in my opinion, that will beat the larger efficiency questions, in my opinion.
Love that. Well, guys, I want to thank you, both of you, for this awesome conversation. I learned a lot just hearing your perspectives and how you guys both think about it.
Same here.
Yeah.
Thanks so much.
Yeah, this is a great time. Again, for anyone listening, we're going to hopefully do more of these things, address some interesting questions about the journey of developing a feature store and some of the other things around that. But I just want to thank you guys, Jim and Venkata. It was such a pleasure speaking with you. We really appreciate the time that you guys made for the MLOps community. And I wish you guys a great weekend. And for everyone listening, I hope you guys enjoy this.
And I think it's worth also mentioning, for those who have stuck around up until now, that we are in the MLOps community. We're starting to do model labs, and we're looking for 2 to 3 engineers who have already been putting some models into production, because what we want to do, and David, you can probably help me explain this more, but we want to create like voyages or cohorts where we can all have a certain business problem and then go about solving it, and create teams and then go and solve these business problems. But to set up that whole infrastructure and the pipelines and the business problem, we need a team to go about that. So if anybody out there is listening and they want to join us, get in touch. We're not that hard to get a hold of.
We're going to be releasing a video real soon about it, so I'm going to save it for that. But yeah, guys, please stay tuned.
Should I not have shared that?
No, definitely.
We can cut it out in post. It's all right.
But yeah, guys, thank you so much. Hope you guys have a great rest of the day. You guys take care. Bye, guys.
See you in Slack.
Yeah.